Yeah.
Okay. Alright, so let's see. First of all, minimize this on my tablet. And let's write this function over here.
We don't have to do 4 because that's not going to be on the test, but we can go through it, I guess. Accidentally said that.
4 illustrates all of the things you need to do.
Okay.
So I suggest we do. If you know how to do 4, then you're going to know how to do most everything. That's plus 2x minus 8y. I want to make sure I get it.
Yeah.
I'm reading it. For some reason, I can't blow up that document anymore. Is that the right equation?
Yeah.
Okay. So, find the vertex by completing the square. What does vertex format look like?
Oh, dang it. I don't remember. It's.
You need to remember it. It's critical. It's the most important format for quadratics. It's a times x minus h squared plus k. Most all math problems, you want to start from the general formula. That's just the way to do it. Because if I know that this is what it's supposed to look like, I know how to proceed over here on the left. Okay, so what do I want to do on the left? First of all,
what do I want to do? I don't.
I'll solve for y. I want to make it look like this thing on the right. Well, this thing on the right has y all by itself on the left side of the equation.
Okay.
Okay, so I'm going to move the 8y to the other side. This. And I'm going to divide both sides by 8. That's equal to y.
Okay.
Okay. Now, I'll switch it around just so we don't confuse you. I can always write that this way. Okay. Now, they didn't start it with an easy one. A little bit of a hard one. We got to make it look like that. And they specifically said complete the square to do it.
Okay.
Okay? Well, whenever you're completing the square, you're basically putting parentheses around that. You're going to add a term inside the parentheses so that I can write it in an x minus h squared manner. And then k will be whatever k comes out to be.
Okay.
Okay? What's the first thing you have to do before you can complete the square?
Getting the squared,
Coefficient of the x squared term has to be what?
The x squared term.
What's the coefficient of the x squared term right now?
The 1/8.
What does it have to be before I can even begin to complete the square?
Does that be 8/1? No.
It has to be 1.
Yeah. Okay.
Always has to be 1. So whatever number is inside there, you got to factor it out. Okay?
Okay.
So I know I got to divide by 1/8. So I'm factoring out the 1/8. What's left over? I'm going to leave a little extra room because I'm going to complete the square after this. I hate starting out with super hard problems like this because I'd rather start out with an easy one, but this is the one they gave me.
Okay.
It's easier to learn when you start out with easy problems. It's just a methodology. It's all you memorize. Okay?
Okay.
But you have to know how to figure out, if you factor out a 1/8, what's left inside of the premise.
Just x squared.
No.
Wait.
Remember, when I'm done with this line right here, it's got to be exactly the same as that. I can't change it.
Okay.
So in order for it to be exactly the same, what has to, in other words, if I left it like you've given it to me, then it would convert to 1/8 x squared minus 7/8. Well, that's not what we're looking at. We're looking at 1/8 x squared plus 1/4 x minus 7/8. So I need another term in there.
The x squared plus.
What you're doing when you factor out a 1/8 is you're dividing every term by 1/8. So what do you get when you divide 1/4 by 1/8?
One over 32.
Nope. How do you divide by a fraction?
Wait, hold on. Hold on. The one.
How do you divide by a fraction? That is a basic question I need you to know. Because you can't even do arithmetic if you don't know how to divide by a fraction.
So multiplying it, cause when you flip it and you multiply.
Okay. So 1/4 divided by 1/8 is 1/4 times. I'm flipping only the denominator. What's that equal to?
2.
Okay. So that's what that needs to be, is 2x. Okay? Now, check yourself. Always get in the habit, as you go from row to row, of checking yourself to make sure you didn't make a mistake. Is my bottom line the same equation as the line above it? If I were to redistribute it, in other words, if I were to multiply it by 1/8, both terms, do I get the same thing that I started with?
Yeah.
Okay. Now we're ready to complete the square. Okay, except I wrote a little too big here. Smaller. That's plus 2x. Okay, now what you're doing when you're completing the square is you are going to add a number such that I will be able to write this term as x plus some number squared, quantity, which is what, notice what Vertex format is. It's x minus h squared. So the way you convert what I've got now into an x minus h squared is by completing the square. And completing the square is just memorizing a process. Do you remember what the process is?
No. Wait. No, I forgot. No.
Take half the coefficient of the x term, square.
Take half of that. What?
What's the coefficient of the x term?
Of the x.
Here's the x term. What's x coefficient?
2.
What's half of that?
Half of 2.
That's what you do, is you take half of that coefficient.
Just do
What is
1.
it? And then square it.
1.
Okay, so that's what I'm adding, is 1. Okay? Now, I can't just arbitrarily add numbers like I did. I've changed it. The bottom line is no longer the same as the top line. I added a number to the right side of the equation when I wrote a 1 in there. But how much did I really add to the right side of the equation? Because I can balance it out. I can balance it out by subtracting that same number and combining it with that minus 7/8. So what number, how much did I add to the right side of the equation when I wrote a 1 in there?
Just 1.
Is that 1 being multiplied by?
The 1/8.
Aha. So what I really added was 1/8. I didn't add 1.
Oh, okay.
I added 1/8. In other words, you have to multiply that factor that you took out. Notice what that's going to be. That's going to be A, that 1/8. Okay?
Okay.
But anyway, I added 1/8, and since I'm on the same side of the equation, to balance it out, I have to subtract 1/8. You with me?
Yeah.
Now the bottom line is exactly the same as the line above it. You can never change it. You can only modify it. But in that modification, now, because I completed the square with that term right there, I can write that as x plus 1 squared. That's the whole point of completing the square. Combine these two numbers, minus 7/8 minus 1/8 is minus 8/8 or minus 1.
Okay.
Now look what we have. What do we have? We have it in perfect vertex format. This thing over here on the right.
Mm-hmm.
So, on the general formula on the right, what is H and K?
H is 1 and then K is 1. So
What in general? They want it in vertex format. What's the advantage of vertex format? You can find the vertex instantly. What is the vertex?
what? -1?
H is the x-coordinate of the vertex.
Oh.
K is what?
The Y.
Okay. So our vertex is really easy to find once you get it in vertex format. Well, we got it in vertex format. What's H for our equation? Remember, it says x minus H is the format.
So -1.
Ah, very good. And what is K?
-1.
Very good. So, that's the answer. Find the vertex by completing the square. H equals -1, K equals -1. And in case they're wondering, the equation is y equals 1/8 times x plus 1 squared minus 1. So that is the same equation they gave us. It's just that we manipulated it a bunch of times. Notice that it took 6 steps for us to get that quadratic equation in a vertex format. And one of those steps was completing the square. Okay?
Okay.
All right. Now, we're going to switch up gears here because they're talking about directrix. The moment they're talking about directrix, then we're dealing with conic section. And it's a new way of looking at quadratics, not the way you're used to looking at. Okay?
Okay.
In other words, you're used to looking at parabolas like, well, let's see, this was a -1, -1, and it's really broad and flat. So that's the parabola we're looking at, where the vertex is -1, -1. Okay?
Okay.
Now, when you look at parabolas as conic sections, everything's pretty much the same, but there's another key feature of a parabola, and it's actually the official mathematical definition of a parabola. And that is that there is a focus somewhere right there. and there is a directrix right there, so that the distance from the vertex to that focus is the same as the distance from the vertex to that directrix. In other words, this distance here, I'm going to draw a different color, this distance here is the same as that vertical distance there. Okay, we'll put a hash mark, like geometry does. Okay, so that's different. And there's a lot of reasons why they add that, because parabolas have reflective problems, where if you shine a light or starlight into a parabola, it always bounces to that focus. This is called a focus point. Okay, that's the focus. That's the way flashlights work. That's the way receivers get direct TV work. Anytime you see a thing on top of somebody's roof, that's a parabolic receiver. And you'll notice that right about at this spot where I've drawn the X, there's a big instrument there. That's picking up all the rays from the satellite pointed at. This receiver is where your television signal goes into. You can watch it. Okay? So parabolas have a lot of interesting properties that you've never talked about before conic sections. And one of them is this directrix. And the official definition of a parabola actually says that no matter where you're at on the parabola, we'll pick a point right there, the distance to the focus is exactly the same as the distance to the directrix, no matter where you're at. If I'm way up here, that distance is the same as that distance. Okay? So that's why the directrix is important.
Okay.
Now, when you are dealing with parabolas as conic sections, they don't use the vertex format. They use a different format. Okay? It's not that different. I'm going to erase what I've written here. I'll leave that format up there. Remove the K on the other side. And they take this A and make it 1 over 4P. And you multiply both sides by 4P and end up with this equation. And this is the general equation of a parabola. And P is this focal distance. Okay? So if you're trying to find the directrix, you got to find P. Now, I don't know whether they've taught you this new format or not. Half the schools use this format. The other half use the vertex format, and they tell you that A equals 1 over 4P. You can do either one. Either one are exactly the same.
Okay.
The advantage of using this secondary format is that you solve for P right away. Okay?
Okay.
So, if we take our equation here that we've got down here on the lower left, and we put it into this format, we'll figure out what P is. We know where the vertex is. We can find the directrix. Okay?
Okay.
So, first of all, I'm going to multiply. You see this equation on the lower left?
Yeah.
I'm going to add 1. Like that. I'm going to multiply both sides by 8 now. And what that leaves on the right is x plus 1 squared. So that is my standard format. Now, I still have it in semi-vertex form. In other words, y minus k, so k is definitely -1. H is still -1. So my vertex didn't change. The advantage is that now I have it in, well, I don't even know what they call this, conic parabolic format, or parabolic format, we'll call it, instead of vertex format. Okay?
Okay.
If we're trying to figure out what P is, and this is my equation, what is P?
Wouldn't 2?
Yes. P equals 2. So this distance right here is 2 units, and it's 2 units to the directrix. So, to answer question B, the directrix is a line. We draw it as a dotted line because you don't usually draw it. You're drawing parabolas. Nonetheless, it's there, and it's an invisible line. But there still is an equation of that line. What is the equation of the directrix?
The
blue dotted line that I've drawn, covering up now with red.
will
What's
not
the
be
equation of that?
the y equals k minus p, or the one.
You're close. You're really close. It's y equal because it's a horizontal line, and it's the equation of a line. So we need y equals some number. What's that number?
The y equals.
It's 2 units below the vertex. Where's the vertex? What's the y coordinate of the vertex?
The y coordinate.
Yeah, I've got it labeled on my drawing.
The 8 or no?
No. Okay. Hold on. That's the vertex. -1, comma, -1.
Oh.
That's the x and the y coordinate of this vertex right there.
Okay.
Every parabola has a vertex. That's the most important thing to figure out first, the vertex. Okay? Now, if I go 2 units down from there, where am I at on the y-axis?
2 units down will be -3.
Okay, that's the equation of that line. Y equal -3. Y equal -3 is that dotted blue line. Okay?
Okay.
And part C. What is the axis of symmetry? Let me draw the axis of symmetry. Every parabola has an axis of symmetry that is also an invisible line. It goes through the vertex, and the parabola is symmetrical about that. It's the equation of that line. And that's also a line, so it needs an equation of a line. It's a vertical line, so it must be x equals something.
-1.
Okay. So that's the axis of symmetry, is x equal -1. Now, let's see. Here, D. Do you have this paper sitting in front of you by chance?
Yeah.
What does that say?
Find the range in interval notation.
Okay. The range refers to which variable?
Would it be the axis of symmetry or no?
No. Domain refers to the x variable.
Oh, so the y.
Range refers to the y variable.
Okay.
So what they're asking you is what are all of the possible values we can have for y? I want your eyes to look up and down, not left and right, up and down. Look on that y-axis.
The y-axis.
What's the lowest value we can have for y?
-1.
What's the highest value?
Infinity.
Very good.
Okay.
And you see why I put a bracket around the -1?
Yeah.
Because it actually can be -1. if you get to that vertex on the parabola, you are at y equal -1. And infinities always have parentheses around, never brackets, because infinity isn't a number, it's a concept. So just remember, you always need parentheses around infinities.
Okay.
And that is interval notation, as opposed to saying y has to be greater than or equal to -1. That would also be a satisfactory answer had they not said interval notation. This is specifically interval notation. You have to have bracket or parentheses on both sides. Okay?
Okay.
Is there a maximum or minimum? Look at my curve, parabola, pink.
Would the minimum be -1?
So first of all, I say, is there a maximum or a minimum? The answer to that.
Oh, there's a minimum.
Yes, the answer is yes, there is a maximum or a minimum. Not all functions have a maximum or a minimum. Okay. In other words, if I draw this, it does not have a maximum. Maximum is infinity. The minimum is negative infinity, which means it does not have a maximum or a minimum. Okay. So only certain types of functions are going to have maximums or minimums. This one does. There is a value there that you do not see anything lower than that. So what does this make that? What does this have? You said a minimum, I think?
Yeah.
Right, it has a minimum. Find the domain in interval notation. Okay. Would have actually been it would have been nice if they would have said, what is the minimum? So I will ask him, what is the minimum value?
-1.
Yeah, there's a minimum and it's -1. Okay. Now, the domain, I want you to look at the x-axis. I want you to look your eyes left and right only. And what is the domain of this parabola and all parabolas that are up and down like this?
-infinity and infinity.
Yeah. Domain or interval notation, I got to write it like that. I could also say x is all reals, although that's not interval notation. Okay, and G. On what intervals is the function increasing and decreasing? Write this in interval notation. Okay, here I need to expand this a little bit, figure out where I'm going to write. Well, I got all of this stuff. We know what P is, that's right. Because that means the focus is at +1. Focus is at -1 +1. Where I've drawn the x above the parabola. In other words, if you were building this, you would build it 2 feet above the vertex. If you were building a dish, parabolic dish, where you're going to take this parabola, rotate it around that axis, you have a dish, you want to put a receiver somewhere in it. The receiver would go 2 feet above, middle, bottom, put the receiver there, and every ray that comes into that parabola is going to get reflected to that receiver. Okay. So the reflective properties of the parabola really what make it the most interesting thing. We design all of our telescopes, flashlights. Most every receiver on the planet is in the shape of a parabola for this reason. So this focal point, that x was, is a very important point on any parabola. All right, so where is this function increasing? On what interval?
The -1.
You want to start from negative infinity. First of all, they're referring to the x coordinate. only. I'm not talking about the y-coordinate. They want to know, and that can be confusing in math, as to when they're asking, especially on questions like this, where is it increasing and decreasing? They're referring on the x-axis, where is it increasing and decreasing? Okay? So, if you start all the way to the far left, you're way up here at negative infinity. Is it decreasing at that point?
Yeah.
Until where? Where does it stop decreasing? So it starts decreasing at negative infinity on the x-axis.
Would it stop at -1?
Uh-huh. And that is a bracket. No, it isn't. Excuse me. That is in a parenthesis. Because at -1, it is no longer decreasing. At -1, it's flat. So we go right up to -1. Okay? And excuse me, that was decreasing, right? Which we're going downhill. So where is it increasing? And interval notation.
The -1 to infinity.
In parentheses or bracket also.
Parentheses.
Comma.
Infinity.
Because yeah, from here all the way to x or all the way to infinity on the x-axis, it's always going up, always increasing. Okay, and these are precalculus questions. In other words, increasing and decreasing functions really have to do more with calculus than anything else. That's the only interest you really have it is for calculus.
Okay.
What year are you in?
I'm a senior.
Okay. So you won't be taking high school calculus, but you might take calculus in college.
Yeah.
They require calculus for an awful lot of things. I mean, even if you're an econ major, business major, they probably want you to take calculus.
Okay.
And the final, what does H say? I can't read it.
Find the focus.
We did. What's the coordinates of that focus?
-1, 1.
Finally, they want us to graph it, and I've done that already. I find it actually easier to graph it at the beginning, and then it's really easy to answer questions like where it's increasing, where it's decreasing, and where the axis of symmetry is, and things like that.
Okay.
So once you find the vertex, and you know that it's flatter than a regular parabola by 1/8, because if it was just a normal looking parabola like that, then that would be a 1, it would be 1/8. So this is flattened out considerably by the fact that that says 1/8. Okay?
Okay.
So, we learned an awful lot about parabolas from this problem. It basically asked every single thing that required us to know about 8 different things. First of all, you put it into vertex format, so you know where the vertex is, and then you alter that vertex format just a little bit to put it in, let's call that parabola vertex format. That allows you to figure out what P is, so you can figure out the focus and the directrix. You can graph it, you can call its domain, range, and where it's decreasing and where it's increasing. Everything we need to know about that quadratic. Okay, so I'm going to erase all of that. And go to the next page. I'll see if I can read this. Yeah. it up at all. I won't be able to pull this up, but I can at least see it. Okay, so find the domain of the function. Let's start up here on the left. Alpha of x equals x over, if I miswrite these, but I can't read them, holler. I think that's what it says.
Yeah, that one's right.
Okay, so how do we find the domain of this function? Remember what domain is. Domain is all allowable values for x.
Okay.
And it's actually easier to think about domain as what can x not be. Because usually, if I say y equals x plus 2, well, x can be anything. It can be any negative number. It can be 0. It can be a fraction, a positive fraction. It can be a billion, a million. There's no restriction. The domain on this would be all real numbers, just like that parabola. But what is different about this equation? Is there any value that x cannot be? What's the number one rule of all math?
Can it not be 2?
Exactly. The number one rule of all math is you cannot divide by 0.
Okay.
No matter what country you're studying math in, that's always the first rule. You cannot divide by 0. So the one value that x cannot be is 2. Is there anything else?
I don't think.
No. Is what I did was I set 2x minus 4 equal to 0, solved it. That's what would make the denominator 0, so therefore that's what it can be.
Okay.
Now, let's write that in interval notation. It can be any number on the number line except 2.
The negative infinity. Well, infinity, but yeah, negative infinity is the 2.
Well, the reason we use interval notation is because you can list it as intervals. And then that's in combination with, that's what that U means.
Union.
Yeah, union.
2 infinity.
In other words, that is all real numbers except 2.
Okay.
And notice I used the parentheses next to the 2's because it can't be 2. In other words, if it could be 2, I'd use a bracket.
Okay.
All right? So basically, we're going to look at each of these functions. And we're going to try to figure out what restriction is actually on. Not all functions have restrictions, but certainly when you're dividing by a variable, there's going to be a restriction because you can't divide by 0. And what is that? Minus what?
Minus 3.
When you have a radical sign, what can't you do?
Radical sign, you can't,
What can you not take the square root of?
0?
No, you actually can't take it at 0. It's 0. You answer it. You can't take it at negative numbers.
Okay.
So when you see a square root sign, you know whatever is under the radical has to be greater than or equal to 0.
Okay.
So I'm going to start out that exact way. That's what's inside the radical sign. I'm going to set it greater than or equal to 0. Because I don't have any problem with taking the square root of 0. That's 0.
Yeah.
I can't take the square root of negative anything. Okay. So if I solve that, I get that. That's my answer. As long as x is greater than negative 3, I will not be taking the square root of a negative number.
So it would be bracket negative 3 to infinity?
Very good. That was my next question. What is that in interval notation?
Okay.
And the last natural log
Yeah.
of what?
Negative 2 plus x.
Now, the natural log functions are a lot like the radical, the square root, except you can't even take the natural log of 0.
Okay.
In other words, you can only take logs of positive numbers.
Okay.
You can't take logs of negative numbers. You can't take logs of 0. So what do I have to solve? What do I have to do to solve this as to what x can be?
Put a positive number in there?
No.
Oh.
Just take whatever the argument is. That's the argument. Make it greater than or equal to 0. That's what we need.
Okay.
Minus 2 plus x has to be greater than or equal to 0. Now solve that.
So then you do x is greater or equal to 2.
Okay, now put that in interval notation.
2 and negative infinity in parentheses.
Not negative infinity.
I mean just infinity, not negative.
And the left side is actually, excuse me, I've got to back up here. That has to be greater than 0. It cannot be equal to 0. All right? So it's just a greater than sign.
Okay.
It's not a greater than or equal sign. Sorry about that. Okay? So if x has to be greater than 2, am I going to start with a bracket or a parenthesis?
Parentheses.
Okay. And 2 to infinity. So those are the 3 domains in interval notation for that problem.
Okay.
All right. Got 15 minutes here. Find the difference quotient for the function negative 5x minus 6.
Yeah.
The difference quotient. What do they mean by that? Because there's a couple of them. There is the difference for quotient when you're talking about the first derivative for calculus. It's called the limit difference quotient. But if you're not talking about calculus, I'm not exactly sure what they mean by the difference quotient.
Oh. I'm not positive.
Let me ask you if you've ever had this. This looks familiar. See if they've taught you this. That is the limit difference quotient.
Yeah.
At h goes to 0. Is that what they're talking about?
Yeah, I think so. That's the problem I have.
Okay. This is calculus. It's no longer precalculus. This, in fact, is probably the first thing in calculus. Actually, they'll teach you limits for 2 or 3 weeks, and then they'll go straight into differential calculus. This is the definition of the first derivative.
Okay.
Okay? So, we got just about enough time to figure out how to do this. Although you and I have never talked about limits before. So, we can only do so much. In other words, we've gone from Algebra 2 here to calculus 1 hour. We can't really cover everything. Tell me what f of x plus h is.
Negative 5.
Times.
X plus h. And then minus 6.
Okay. So, I got f of x. I got f of x plus h. So let's do this. What's our numerator going to be?
The negative 5x.
And I'm going to go ahead and multiply that out. Reverse distribute it.
And then minus, 5h. 6.
So that's the first thing. That's f of x plus h.
Okay.
I'm going to put parentheses around it just for clarification, because the next thing is going to be subtracting f of x. Oh, what's f of x?
Minus 5x, 8x, and then minus 6.
Be very, very careful here to not drop negative signs. Okay? In other words, every single negative sign you see in that numerator is critically vital. You drop one of them, you're getting the wrong answer.
Okay.
Okay? Now, let's simplify that numerator.
So
Notice that turns into a plus 5x, and we got a minus 5x over there, so those cancel out. That minus 6 cancels out with the plus 6, so those cancel out.
Okay.
What I've got left on the top is minus 5h only divided by h. Well, if I'm trying to find the limit of that as h goes to 0, I'm going to be dividing by 0, but not if I cancel those h's out first. Now, that limit is minus 5 as h goes to 0.
Okay.
So the question is find the difference quotient. The difference quotient is minus 5, presuming that they want the limit. In other words, presuming that's what they want.
Yeah.
And incidentally, I should add that this is about the hardest part of differential calculus. Everything that follows this is easier.
Okay.
That might seem strange to you as to why they start out calculus teaching you the most difficult thing. But it's actually quite common in that. If you remember your geometry, what they start you out with? Proofs.
Yeah.
Algebra 2, what they start you out with? Linear programming. Objective functions. Stuff like that.
Mm-hmm.
So I'm not sure why. I don't agree with it. If I'm teaching math, I'm going to go easy, medium, hard. Always. Just like if I'm teaching somebody how to ski, I'm going to start them off on the bunny slopes, and then the green slopes, and then the medium slopes, and then the expert slopes. I'm not going to drop you on the expert slope and say, here, ski. Yet that's kind of what they do with math.
Yeah, that's
Every
weird.
time you learn a new discipline, the very first thing they hit you with is usually the hardest of the whole semester. I guarantee you, if you take a calculus course next year, you will struggle with this quotient difference. As these functions get more and more complicated, this whole thing becomes harder and harder to do. It becomes a giant algebra headache, is what it becomes. With a simple function like this, it's relatively easy. As you saw, there wasn't much to doing this. But as they get more complicated, it gets a lot harder.
Okay.
Okay, we got more time. Let's look at the next one. Okay, we have a new function. Let's write it. Make sure I write this correctly, because I can just barely read it. Is that cubed or squared?
Squared.
Yeah, I was going to say it must be squared. They're asking for the discriminant. No such thing as a discriminant on a cubic function. So, what's the discriminant? What's the formula for the discriminant? All these basic formulas are the most important thing you can remember. Because if you can start with a basic formula, then you can plug in from there. But if you don't know the basic formula, you got no chance.
I don't remember the discriminant one.
Remember your quadratic formula.
Isn't it that D equals?
You know what you really could use is flashcards.
Yeah.
Because you're not going to do well on this test if you don't remember these basic formulas. You just aren't. So if I were you, I'd get 5 or 6 index cards. On one side, write discriminant, and on the other side, write b squared minus 4ac. Get another flashcard and write quadratic formula on one side, And on the other side, it's x equals minus b plus or minus b squared minus 4ac all over 2a. Those are two formulas you just absolutely have to know. Okay? Notice what the discriminant is. It's whatever inside that radical sign. So if you have the discriminant memorized, it makes it easier to memorize the quadratic formula. But the discriminant is what they're asking about. And the discriminant is not the square root of b squared minus 4ac. Discriminant is b squared minus 4ac. Well, in this formula up here, what's a, b, and c?
A would be 5. And then B would be -2. And then C would be -1.
So tell me what b squared minus 4ac is. It's b squared.
So it'd be 5 squared, so 25.
B squared.
Oh, -2.
There's nothing wrong with doing it like this. I actually prefer people to do it one step at a time. I mean exactly like this. Put parentheses around everything. What's A?
5.
C?
-1.
Okay. Now simplify.
-4.
No, that's not -4. -2 squared is 4.
Oh, yeah.
Regardless if B is a positive or a negative number, B squared is always going to be positive.
Okay.
Okay. Minus, what is all of this? That's really the next thing. Okay.
20.
Minus 20.
Yeah.
So it's minus a minus 20. Again, you cannot drop negative signs. You will not get the right answer if you do. A negative sign is every bit as important as any other thing I'm writing. So now what is 4 minus a minus 20?
24.
Okay. The importance of the discriminant is that if it is positive, you're going to have two real solutions to this quadratic, two real zeros. If it is negative, you're going to have two imaginary zeros.
Okay.
If it is exactly 0, then you're going to have one real solution. So let me draw. Okay. First of all, we got a positive discriminant. It means we've got two real zeros. Those are the zeros right there. So that parabola has to cross the x-axis to show real zeros. Okay?
Mm-hmm.
Now let's say that the discriminant is negative. Now we're looking at a quadratic that does not cross the x-axis. That blue parabola has no real zeros. It has two complex zeros only. And if the discriminant is exactly 0, you have exactly 1 0. Touches the x-axis in one spot right there. And so that's why the discriminant is important. Because a lot of times, when you're dealing with a quadratic, you might not have to solve it. If this is a real-life problem and you're trying to figure out, well, what are the zeros, and you discover the discriminant is a negative number, well, you can confidently say there are no real zeros and be done. Say that you got two complex zeros on there. So you wouldn't go any further. So a lot of times, instead of using the entire quadratic formula, your first step is to figure out what that discriminant is, and then that tells you a lot.
Okay.
As to whether it's positive or negative.
Okay.
All right. That's probably a good place to stop. Covered a lot there. I hope it's not too much in too short a period of time. Wish we'd have had a little more time to cover some of this stuff because it takes more time. This is what we covered today is too much to cover in 1 hour. Hopefully you'll retain enough of it for 24 hours to do well on the test.
Yeah.
All right, Haley. Good luck, and if I don't talk to you again until next semester, have a Merry Christmas. Happy New Year.
Merry Christmas. Thank you so much.
You're welcome. Bye-bye.
Bye. Okay.